Today is the 6th of March 2024, and this will be the second video on terminating and recurring decimals. Okay, thank you to all my subscribers. I appreciate you a lot. Okay, thank you very much. Please, if you've not considered subscribing, I will appreciate it if you consider it. Okay, and then those if you should watch, share, like, follow. Okay, let's share the platform and help somebody else. Okay, please, if the account is not yours, ask permission from the account holder. Okay, don't misuse somebody's account, okay, and get them into trouble. Okay, in the comment section you normally see please follow my notes/scripts. Okay, so for instance, this is 0.425. so if you hear 452 or 25, go by the notes, please. And then please beware of scammers. Okay, take care of yourself online. Okay, even the people scamming are scamming themselves, so you see how desperate they are. So please beware of them. Okay, if somebody comes into your account, enters into your private message asking for donation under this platform, I'm not using this platform for that. Okay, if you are not sure, put it in the comment section, I'll let you know. But if I haven't said it, like you are hearing me saying it now, don't fall for it. Okay, if I need to tell you something, I'll use this medium to tell you that. Okay, as I'm saying now. Okay, now recap. We started watching looking at recurring and terminating decimals. We've done that before. Okay, I even did some possible exam questions from the higher paper on that. Okay, but I just wanted to elaborate a little bit. Okay, how you can spot a recurring and terminating decimal or a fraction that will give you a terminating or a recurring decimal. So for instance, if the prime, you have prime factors of 2 and 5, they will terminate. But immediately you have other prime factors like 3, they are not going to terminate. Okay, so like 2 to the power 2 something to the power 8 would something divided by 8, denominator of 8 would terminate, but a denominator of 15 will not will recur because of 3 times 5. Okay, so these are things you can look out for when you are doing your work, especially in the non-calculator paper. Okay, it will help you a lot. Now, our starter is an example So we are going to change 17 over 40. It's a fraction into a decimal. Okay, now 4 is the same as 4 times 10. Okay, and you can have 2 to the power 2. So immediately you see that, you know that this is going to terminate. Okay, without even being told. So I'm going to change it into a fraction using the long division method, which I have done in earlier videos. So 17 go into the inside of this partial box, and the 40 is outside. Now we know 40 cannot go into 70, so we put a decimal and then we add 0. How many 40 do you have in 170? You have 4. Okay, 4 times 40 is 160. When you subtract, you get 0. Okay, then you add another 0. How many 40 do you have in 100? 2. 2 times 40 is 80. Okay, so 80 out of 100 will give you 20. Okay, we add another 0. How many 40 do we have in 200? 5. 200 minus 200 will give you 0. Okay, so 17 over 40 will give us a decimal of 0.425, which terminates. Okay, so we've changed a terminating decimal into a fraction into a terminating decimal. Okay, now that is our starter. Today, the first example, we are changing recurring decimal to fraction. Okay, now we just change a fraction into a decimal, and we know that it terminated, it stopped. Okay, now if you are given a recurring decimal to change into a fraction, how would you know? Are you going to put all over 1000000? If it's a non-calculator paper, you are going to be confused at a point. So I'm going to show you a method you can use. So you can say let R, okay, because it reoccur, let R be 0.555555. How many fives they give you? Okay, so I'm going to times both sides of the equation by 10. So 10R will be equal to, now if I times this whole recurring decimal by 10, the point moves there, so I have 5.55555, and that is what I want to get, because I want to get rid of all these 0.5s. Okay, so now this is my first equation here, and that's my second. So I'm going to subtract r this equation, the first one that I've labeled 1, from 2. So 10r minus r will give me 9r. Now look at this, 5.5555 minus 0.5555. So all these 555s are going to be off. So I only have the 5 here. So I've written it here. The first equation minus the second. So 10r minus r will give me 9r. 5.5555 minus 0.55555 will give me 5. Okay, so now r will be equal to 5 over 9. Now look at the denominator again, 3 to the power 2, or 3 times 3. Okay, now because of the 3 as prime factor, that is why our decimal terminate. So you can guess in an exam, when they give you 4 sets of fractions and ask you which one terminates, without even solving, this is what you should be looking at. Okay, if it's a non-calculator paper, this is some of the things you should be looking for. If it's a calculator paper, you can look for that and check. Okay, the question I solved with you earlier on, I hadn't shown you this method, so I didn't use that method. Okay, but if we get subsequent exam question, I will use this method to show you, and I might bring some of this method in the starters, so that because now I've done a video on it, for you to understand some of these things. Okay, so 5 over 9, our fraction, it will recur. So you will have 0.55555. Okay, that is our first part. So let's go on to the second. What I have for you today. So our next example. Okay, if 2 digits recur, multiply by 100. So what I mean here is, you know, this is just 1 digit, 0.5555. So we can't let r and then we multiply by 1. But if it's 2 digits, like 0.515151, then instead of multiply by 10, we'll multiply by 5, because we want a situation where we can get rid of all these recurring numbers. Okay, and then simplify it to this form. Okay, so I'll show you what I mean by that again. So we are going to look at another example. So now change 0.181818 into a fraction. So assuming it was 0.1111, we'll just multiply by 10 and subtract. Now, what can we do? We'll say let r again be 0.181818. Okay, if we can multiply by 10, but we'll get 1.10 10R will be 1.18. It doesn't help us get rid of the recurring numbers. So we multiply by what? 100. So if you multiply by 100, the decimal moves forward twice. So now we have 100R, okay, will be equal to 18.181818. So immediately I subtract 100R, this equation, from that equation. I'm going to get 100 minus R here, minus R. Okay, 100 minus R, okay, which will give me 99R, and then I have 18.181818 minus 0.1818. okay, the trick is I want to get rid of the recurring part of the fraction. Okay, so now I have 99R equals 18. So R will be equal to 18 divided by 99. Okay, so again, 18, the numerator, divided by 9, I have 2. 99 divided by 9, I have 11. Now 11 is a prime factor, and because it's not 2 or 5, that is why it's recurring. Okay, so this is another decimal. So assuming I have this and then another 3 or 4 set of fractions, and they ask me which one will recur, okay, then I'll go for this one because it hasn't got prime factors of 2 and 5. Okay, so now I know that, and then I don't normally these questions come in the non-calculator paper. So now I know that 0.181818 terminates. I don't want to be repeating the 1, so I put 2 dots at the end, assuming it's just like 0.555 as we saw. Then I can have the 0.5 to put that there to say that it recurs. Okay, but now to shorten it, I have the 1/8 cut off and then 2 dots on top of the 1/8. So that means 1/8 recur. And then my decimal here, my fraction is 2/11. Let's look at another example. Okay, now change the recurring decimal. 0.5181818. Okay, so this is also recurring, so I need to change this into a fraction. So let's see how we go about it. Okay, let R be 0.5181818. Okay, so if I multiply by 10, I have 10R equals 5.181818. Okay, now I can multiply again by 100. But if I do that, I'm going to get 100R equals 51.818181. But if I subtract this from that, I'm not going to get the whole number I want. So I'll multiply again by 1,000. Okay, so if I multiply by 1,000, the first let R here, this one, I have, that is 3 zeros. So I have 1,000R equals 518.18.18. Okay, so now look at it. I can take the 1818 off. Okay, so instead of going for R, I'll go for 5.181818. Okay, so now I have this equation 3 here and that equation 1 here. Okay, so now 1,000R minus 10R will be equal to, look at this, 518, and that is 5. Okay, so now I can get rid of the 181.1818 parts, but I have 5 points here. Okay, and then I have 518. So 518 minus 5 will give me 513, and then the decimal can take care of itself. You can subtract that. So now 990R, okay, remember it's 1,000R minus 10R. So we multiply R by 10, and then we multiply again by 100, okay, and then by 1,000. So we know that if we subtract the 1,000R from the 10R, then we can have R equals 513, okay, divided by 990. So here again, if you look at it carefully, this can give you 990. So 3 or 9 times, or 99 times 10. And 99 has 3 as a prime factor in it. That is why it's going to recur. Okay, so this recurring decimal will give us 513 divided by 990. Okay, so this is another non-calculator paper. Now let's look at another example. So we've been looking at terminating and recurring decimal, and we've been looking at the denominator to see which one would terminate, okay, and which one would recur. Watch last video, link it to today's video, and then you will see the pattern. Okay, you see the picture clearly. So this is another example. Show that this is a non-calculator paper. Okay, show that 0.4777 will be equal to 43/100. So immediately they ask you to show Okay, you might have to start from here or there, but with decimals and this kind of work, it's better to start from your left and end on the right. So again, because it's recurring, we said you will use R. So let R be equal to 0.4777. Okay, if we multiply by 10, we have 10R. So the decimal shift. So we'll have 4.77777. Now 4.7777 and 0.4777, even if we subtract, it doesn't help. So we need to get something, a number that will be like 47.777, okay, to subtract from this one. So we'll go ahead again and multiply by 100. When we multiply by 100, the decimal place will move twice. So we have 47.7777. Okay, so 2 minus 1 will give us 100R minus 10R. Okay, so this is 47.7777 minus 4.7777. So now we can get rid of the 0.7777. So if we do that, here we have 90R, which will be equal to 47 minus 4 is 43, and then all these decimals will go away. Okay, so R now, if you divide by 90 on both sides, will be 43 divided by 90. Okay, now again, 9 times 10, and then 9 will give us 3 to the power 2 times 10. So because of the 3, even if it's just 1, it is recurring. Okay, but assuming we had 43 over 80, then it will terminate, because 80 is 8 times 10, or 2 times 2 times 2 times 10, or 2 to the power 4 times 5. Okay, so these are some of the things you should look out for. Okay, so today I thought I'll bring some of these examples to show you. Okay, so now we've proved that, okay, 43 over 90, as they said we should show or prove, equals 0.47777. We've done that here. That is our answer here. Okay, so please share, like, follow, subscribe. I will appreciate it a lot, and thank you very much upfront for doing that. Okay, invite your friends to watch. Okay, don't leave it to last minute and not turn up for the exam. It's different if in the beginning of the year, maybe you registered in a private center and you said, I've registered, and after 1 week you change your mind. and they still kept your name on the list and registered you, okay, that one is different because you have made it aware that you were not going to turn up. But assuming, and then they kept on sending you letters, and then in the end they said, oh, you didn't turn up, that is different, okay. But if you've registered and you've been on the course till this time, please, if you do whatever it takes, okay, in a few months it will be all over. And if you even got A star or C, it's still classed as Gcse. You can get an apprenticeship or anything. So do whatever you can from now, because from now you know the dates, okay. So plan such that you are learning a little bit. Don't wait 2 days and start cramming, okay. You might confuse yourself. Get started little by little by little. Now revise, use your calculator, use your protractor, start putting your units, answer the question, and make sure you understand it properly, so that if it comes, then you can say that, well, it's come, okay, and you did the best you can, and I'll show you your time invested in it will pay off, okay. Thank you for watching my video today, and I'll see you in the next.